All right, let's continue on. Here we go again with another parallel line. Write the equation of a line that is parallel to the line to the right, so we're looking at a graph this time, and passes through the point 2, -3. Well, if I want to write an equation of a parallel line, I need to know the slope, because I know that slopes of parallel lines are the same. So if I look at this original line, again, pick 2 points on that line. I like to pick ones that are close together. I tend to go with the y-intercept if it's a whole number. And then the next one I can find. And looking at those 2 points, though those aren't the only 2 points I could use, but these two work, and it gives me a nice simplified fraction. I have to go up 1 and over 1. So my slope of this line is rise of 1 over run of 1, which simplifies to 1. So the drawn or graphed line here has a slope of 1. If I want to write an equation of a line that's parallel to that line, it's going to still have the same slope of 1. Now the line that we want to draw, though, or get the equation of, is not this line itself. It's a line parallel to it that goes to the point 2, -3. And so we can work to find the equation of that line. We really have 2 choices. We could draw this new line, keeping the slope the same, and come up with the equation that way, which I'll do in a moment. Or we can continue doing what we've been doing. Use the given point, use the slope, and come up with the equation. So I'm going to start with the algebraic way, but the visual way is not wrong, and you're more than welcome to do that. So let's go with our algebraic way, which is to put it into point-slope form. Y minus the y value, it's -3, so we better add, plus 3, equals slope times x minus the x value. Okay? Then we simplify. Get this into point-slope or slope-intercept form. Left side doesn't change on the first step, we just distribute. And if you recognize 1 times anything as itself, or just multiply 1 times x, 1 times -2, we get x minus 2. Then, getting y alone, I'm going to subtract 3 from both sides. And I get y equals x. -2 minus 3 is -5. And there we go. Now let's look at this the visual way. The visual way would be to say, all right, it needs to go through this point. I plotted it already. That's my point 2, -3. And it has to have the same slope. Slope was 1, so this has to have a slope of 1. Up 1 over 1, up 1 over 1, and I can do that. Now, because I really need to be finding that y-intercept, I'm going to reverse this as well. I'm going to keep the pattern going. Up 1 over 1 ends up being the same as down 1, back 1, so that I actually plot the points and see where I get that y-intercept. Now I can draw that line because I actually have the y-intercept plotted. And look at that. Here's my y-intercept down at -5. I drew the line to have slope of 1, so y equals 1x minus 5. It's a good check. And it's also another method to actually find the equation of the line. We could have just graphed it and wrote that equation as well. Now the trouble is when the y-intercept is not a nice whole number, or if it's something that's significantly far from the origin or from the y-axis. Okay. Now we're moving on, same line. We haven't changed which line we're going to work with, the original line, not the one I drew. It says write the equation of a line that's perpendicular to this line on the right that passes through -1, 4. So this time we're going through -1, 4. Perpendicular. Perpendicular does not have the same slope. The slope before was 1. Now my new slope for perpendicular has to be opposite reciprocal. So it was a +1, now it's negative. 1 is the fraction 1 over 1. We actually see it written here. If I flip that over, it's still 1 over 1, which reduces to 1. So our slope hasn't changed. We're going to go ahead and now write the equation of the line that goes through this with this slope, my new slope that's the perpendicular slope, and this point -1, 4. So we have y minus the y value 4 equals m, -1 times x minus, a -1 minus a negatives plus. Now let's continue on to simplify and get our equation. Left side doesn't change. Right side I distribute, -x, or -1x is fine. -1 times +1 is -1. And then here I undo my -4 by adding 4. And I get y equals negative x, negative 1 plus 4 is 3. Y equals negative x plus 3. Okay, again, looking at that here, on the original one, if I'd actually done it graphically, here's the point I need to go through. I need to have the opposite reciprocal slope, so negative 1, so I have to go down 1 and over 1. Well, and look at that, right there's that y-intercept, but just to draw it nicely, I'll do another one. Okay, down 1 over 1. Getting the graph of this line. Okay. Looks like this. And I do see that I have the line drawn that has a slope of negative 1, that has a y-intercept of 3. One more set, and then we'll take a little break again. Okay, this asks me now to write the equation of a line passing through 2 points. Nothing about parallel and perpendicular, so don't start worrying about those yet. Right now we simply want to write the equation of a line passing through 2 points. This is what we did for our last objective. First thing we find is slope. Let's label our point x1, y1, x2, y2. Slope formula, y2 minus y1 over x2 minus x1. Putting those values in, I get 4 minus 7 over negative 2 minus 3, putting my x values in, which gives me negative 3 over negative 5, which reduces to 3/5. Okay, I now have the slope. I need to work and write the equation all the way into slope-intercept form, so we're going to have to do a little bit of work here. We're going to start by putting the point in. Pick a point, whichever point you like. Again, a lot of you are using that first point automatically every time, which is great. So y minus 7 equals, my slope in this case is 3/5, because it isn't anything parallel or perpendicular, it's simply the slope that you're given. So 3/5 times x minus the x value of 3. First thing I'm going to do is distribute. Y minus 7 equals 3/5 x minus 9/5. Then I've got to add 7 to both sides. Sorry for the lack of space. And my new equation becomes y equals, that 7's gone, 3/5 x, negative 9/5 plus 7. If I work that out, we get 26/5. And that's the equation of my line. Clearly, had I graphed that, I would never see that y-intercept exactly at 26/5. So the algebraic way is definitely necessary for many problems. Here we're going to do 2 more. We're going to use this line above in question 17, so we want to write the equation of the line parallel to the line above through the point 6, 1. Well, here's the line above. It has a slope of 3/5, so my parallel line has the same slope, 3/5. And if you're not good at it now, yet, you will be, because here we go again. Y minus the y value of the point, 1, equals slope 3/5 times x minus the x value of the point, 6. All right, now we've got to distribute. I'm just going to go across. Left side doesn't change. Right side, 3/5 times x, 3/5 times minus 6. You get 3/5 x, and then minus 18/5. Almost there. Hopefully you remember. Got to get that y alone, so I'm going to add 1 to undo that minus 1. Do that on both sides. And then we get our equation of our line. The y is now alone. Y equals 3/5 x. And then minus 18/5 plus 1 gives me minus 13/5. There's my line that is parallel to the line in number 17 that goes to the point 6, 1. Okay, one more. You can do it. Now we're going for perpendicular. Back to line in question 17. We want to be perpendicular to that line in question 17 and go through the point negative 9, 5. So perpendicular, opposite reciprocal slope. M equals, before it was 3/5. We see it in a couple different places or all the way at the end here. Slope was 3/5, so now we need opposite, so it's negative. Reciprocal, flip that over. 5/3 this time. Now, write the equation. Y minus the y value 5 equals slope -5/3 times x minus the x value. Distribute. We'll continue across. Y minus 5 doesn't change. Distributing -5/3 x. -5/3 times 9 gives me -15. And then last, get that y alone. We're going to add 5 to both sides. And we get y equals -5/3 x minus 10. We have our equation of our line perpendicular to line in question 17 that goes to the point -9,5. All right, hopefully you're feeling good about that because now it's your turn. I would like you to go back to your practice 2. Go ahead and pause this video and do level 3 again, continuing where you were on the second page in the focus section, but this time I want you to do problems number 8 and 10. Once you've completed these problems, you should have completed that whole second page. I'd like to have those checked in, so please come find one of your teachers and have them check the answers to make sure you've done this correctly. Okay, once you've got those done correctly, you'll go on to the last video.